Hello, hello.
Testing 1 2, testing 1 2.
Not, yep.
All right, now I'm unmuted. Another thing, tell me if I'm coming through. All right, perfect. You're muted again.
Good evening, folks, and welcome to the stpete.net meetup on the Six Figure Developer channel. Let us know how the audio is. This has been a lot of fun coordinating. It seems it's vacation time. Clayton is away with family on vacation. John Ash is here filling in for him. I'm your host, John Calloway, and with us this evening, we have Sean Whitesell going to be talking about microservices. The easy way is the wrong way. So we'll give it a few minutes as folks trickle in. So feel free to grab a pizza, grab a slice of pizza, grab a drink, grab a seat, and we'll get started in just a few minutes. Yeah, Ash, you're still up in Columbus, I assume.
Yep.
I am out on vacation as well, visiting family in Kentucky. Sean, you're out in Tulsa?
Yeah, yeah, out in Tulsa, Oklahoma. And thankfully, we just got done with a lot of the flooding. So a lot of the people that started building the ark have stopped for a while. Yeah, we had some seriously massive flooding. One city had like 13 inches
Oh,
in a
wow.
matter of, it was less than 12 hours. It was massive. Uh, With the
Oh
price
wow.
of wood these days, you can't just go build an ark. I mean, you got to really, get a loan. It's terrible.
So
Yeah, yeah.
Tulsa is where I was born and lived
Really?
my first 2 years of life. Yes,
Nice.
been
Well, at
back
least you
there
got
many
some
times.
good culture at that time then.
My cousins still live out there, so I've been back many times.
Yeah, so folks in chat, feel free to ask any questions. Let us know how the audio is. Let us know how our internet connections are. We are doing the best that we can. And it seems like the all that anybody can ask for the last couple of years, or last year and a half at least. Seems like everyone's remote. This is the stpete.net meetup out of St. Petersburg, Florida. King Filet says, how does this usually go? This is my first meetup. Well, welcome. So the stpete.net meetup usually is an in-person meetup out of St. Petersburg, Florida. We had started live streaming from our in-person presentations and meetings back before the pandemic. And during pandemic, we have gone completely virtual, completely remote, and bringing in guests from all over the country, all over the world. Um, we look to get back into in person at some point in the future when it's safe to do so, and looking for additional speakers, additional presentations. So if anybody has any suggestions on topics they would like to hear or speakers they would like to see, if you yourself want to volunteer or want to volunteer a friend or colleague or coworker, then just let us know. But for this evening, it's all virtual. Feel free to chime in with any questions in chat. Sean will be going into presentation mode shortly and giving his presentation, and we'll try to make sure that any questions, any comments are seen and addressed. If not, then we'll do our best in chat. But do follow us on Meetup. Join in on the conversations there. You can follow us on Twitter. If you're into Facebook, we've got a Facebook group as well. We certainly would enjoy any and all participation. So any way you want to get involved, we would certainly love to have you. So with that, where is everyone joining us from this evening? Ash, Columbus, myself in Kentucky, Sean in Tulsa. What about chat? Who we got in chat this evening? I recognize a few names from Tampa, from St. Pete. King Filet from Tampa. Dylan Coding from Clearwater. Welcome. Surly Dev and the Dev Bots, I think, are out of the UK. Martin, Tampa-ish. Base Bleem out of Bradenton, Florida. Welcome. And we'll give it another minute or two, and then let Sean take it over. Waste Treatment out of Chattanooga. Welcome. Riverview, Florida. Welcome. Good to have you. All right, we're about 10 minutes past the hour. So, Sean, you want to take it away and introduce yourself and go ahead and start the presentation?
Sure. And thank you guys for having me. I really appreciate this. It's a great opportunity to speak to your group. And I do not have Twitch pulled up, so I won't be able to see chat. So if there's any questions, you'll have to relay them to me. But yeah, ask anytime, and I'll be happy to help answer them. So my name is Sean Whitesell, Microsoft MVP. I also run the .NET user group in Tulsa, Oklahoma. And I've got a talk on microservices. So we're going to play with that this evening. And really what we're going to do is kind of focus in on showing that the the microservices architecture takes a lot more consideration than you expect. That's the idea, is where the easy way is the wrong way. You may want to jump in, but if you think you're going to get to production worthy microservices, uh, you really need to stop and take an additional look at so many other aspects that you and bridges that you need to cross as you're defining these and building these out. So tonight we're going to talk about what are microservices, why should you use them, when should you not. We're going to go through a lot of the challenges that you will face when developing microservices. And then, time permitting, we're going to do some decomposition. This will be a high level decomposition. Honestly, by the time we really do a great job with decomposition, that could be a workshop where it's a full week long discussion on that. So we have to stay high level on that. So normally when I give this talk in front of actual people instead of virtual, it's I get an opportunity to ask the audience and say, well, what are microservices? What is your definition of a microservice? And the point is that I'll get 2 or 3 different answers, and there's different answers, and that's kind of the problem. There's so many different there's not one single answer out there. So what I'm going to try to do is provide an answer, and this is just simply my version of a microservice, and that's that they are a tiny monolith with a tight focus on a domain. It's not about the size of the code base, it's not about the number of lines of code, etc. It's about the focus. And that domain is a lot of what we're going to talk about tonight as well, is that it's about the business processes that you're trying to fulfill with the implementation of microservices. That business domain is that focus. And I'm going to be repeating a lot of this as we go through this talk, but if you have a microservice that's going to do processing for your invoices, you should not also have it do the forms for HR eligibility type things. That's 2 separate domains entirely. Now, there's some main tenets with microservices, and that the first one being that they are independent applications. And I will repeat that over and over through this talk. And I'll explain what I mean through that. Is just that each microservice is an independent application. And instead of just being something, a code that you can instantiate and it's running in memory, microservices communicate with each other over a network. And that has a whole layer of problems in and of itself. And microservices should have a single responsibility, that coming back to that focus on a domain. And with that single responsibility, it should do that one domain and do that well. And if there's too much in that domain, such as you maybe have an accounting microservice, and there's so much there that you'll be the judge of that. With that size of that microservice, you may end up splitting that out so that you have an accounts receivable microservice versus an accounts payable microservice. And as well, microservices should be owned by one team of developers. Now, a single team of developers can own more than one microservice, but do not have a microservice owned by multiple teams. The reason why is you're going to have too many differences of opinion, too many different ways of doing things, too many deadlines, etc. And microservices should be individually deployable, meaning that they should be loosely coupled with each other, not tightly coupled. Do not tightly couple your microservices at the code level or even at the data schema level. And we're going to talk a lot of details throughout this talk. And with microservices, it's not about code, it's about an architectural style. It's the way that you design your system so that you're processing the business processes and the flows and the demands that you have split out across the different services. Now, microservices is as opposed to a monolith, and a monolith in and of itself is actually, there's really nothing wrong with that. A monolith is simply a single code base that has different independent functionality, different business, code for different business processes, different domains, but in a single code base. The problem is that most monoliths grow over time, and you end up with what's called a big ball of mud or spaghetti code. And that's when your code base becomes harder and harder to change. It becomes more fragile, more prone for bugs, etc. And so you find yourself in a position where the monolith is just a problem. It becomes a problem case in itself. That's when a lot of people will start looking at microservices. So with microservices, you may be thinking, well, okay, we can take some existing functionality, we'll move this out of the monolith into its own microservice. Other reasons are for creating a brand new microservice for brand new functionality. Maybe business functionality, maybe it's a brand new product line, for example. Now, you will see this, but it's rarely will you see a total migration from a monolithic architecture to a microservices architecture. It has been done, and I'll highlight some of those cases in just a moment. But you're going to see that they had a lot of problems in getting to a total migration. And when we think about microservices architecture, it really is an implementation of distributed computing. The idea is that we're going to take a lot of the business needs, we're going to, in that load, and we're going to split that out into multiple instances of microservices. And the microservices are going to be split out to their domains, and they're going to be shared across different servers as needed. The idea is that you're going to distribute that computational load. But that's kind of where we're going. But why should you do microservices? Now, for the most part, I'll tell you don't do them because of the amount of things that are involved in them. But why do you still see a lot of people doing microservices? Well, the main reason, in my humble but correct opinion, is when that monolith has become such a problem, it's become so fragile, it's going to take so much time for a business to get that code base altered when it comes to new functionality, which you may see is with a lot of businesses, is the time to market is a big factor in their industry. If they can be the leader, if they can be the first one to put out this new functionality, then it's a bigger gain for that company. So the boss comes in, says, we got an idea. Here's what we need to do. We need to get this implemented as quickly as possible. You say, that's fine. We could do this in about 9 months or so. No, we can't do that. That's going to take way too much time. Well, by the time you alter the monolith, by the time you fix all the bugs, by the time you make all the mistakes and et cetera, and have all the misunderstandings, et cetera, right? Then you're still into that 9 months or more. So companies will be like, all right, what's another way of doing this? Let's bring in microservices. Then the monolith is only altered just enough to be calling the microservices where it needs to be in that business process. So what you'll see is that it provides to businesses, they're a lot quicker, a lot safer, and it can provide some more stability to the architecture. With microservices, they do provide you some team autonomy, meaning that you get to have your choice of the best programming language for the job. In one case, for something I was working on where a lot of the main code base areas was done in C sharp. Now we're bringing in some data analytics. Now, C sharp can do data analytics, but Python's a better language for it. Plus, the team of developers in the data analytics department were going to be using Python for that stuff anyway. So that was the microservices development team, and they chose the best language for the job, both with what they know, but and also what it accomplished for that job. And you also, with that team, they got to be focused on that development, meaning that that one team got to focus on that microservice. No other team members outside of them worked on that project. Now, we may have worked as far as how do we call their microservices, what kind of data do we get back, et cetera. So now you're communicating at a feature level than a code level. And if you're already in a position where you're using Agile or Kanban, that works very well with the development of microservices. Service autonomy is a great feature of microservices because you need to focus on that single responsibility. This is coming back to that single domain. If you have an accounting microservice and it's growing and you see a lot of the problems that you were noticing in a monolith, then like I said, you may want to split that out to even more finer grained domains, accounts receivable versus accounts payable. And services should be deployable without other microservices, meaning that if I've got to get my microservice out the door, but I have to wait on another microservice and their code changes, but they're in a different team, you risk different deadlines, different challenges there, and so many other things we're going to talk about through the rest of this talk. By having them deployable without other microservices, they can stay loosely coupled and be able to evolve independently and grow over time. Microservices also provide you scalability. The idea here is that with a monolith, you can put what you need on different servers, but what if that microservice can be ran on Linux instead of Windows? Now you're saving some money. What if you want to put this into virtual machines in the cloud? The idea is that this provides you opportunity to have different choices of the number of instances of the microservice, how much CPU and RAM on the nodes do you need, and how many nodes do you need for that, as well as one of the other things we're going to notice later is when we get into network bandwidth type of management there. Microservices also provide fault isolation, where your problems are not my problems. Stay in your lane, bro. I saw that in a commercial. I don't know why. I just thought that was funny. It just kind of made sense. I'm like, I want to run with this. The idea here is that when you have microservices calling different microservices for a business process, if something were to happen, maybe a payment failed or a bug in the code, it's not stopping another business process in other microservices. You can think of it this way: if you're looking at Amazon and for whatever reason, maybe their payment microservice has a problem and so nobody can get their payments made, well, it's not stopping others from at least logging in or being able to view other items that they can put into their cart. Those various different business processes can stay isolated. So I did mention Amazon, and Amazon, eBay, and Netflix are three of the larger companies that I know of that have gone from a monolithic architecture to a complete microservices architecture, but not cheap and not easily. They spent a ton of time and money making the mistakes, figuring out what they need, rolling some things back, trying various things before they finally got to a position of big success. Netflix, for example, through their process, even created some open source software, one of which is called Eureka, and to help with others with the development of microservices. So it can be done, but expect a lot of time and money on this. So it comes back to the question of, okay, so why should I not use microservices? All right. Well, to be frank, I mean, they're hard. They really are. And this is a little baby picture of John Ash when he was young. So the and it sounds like a cop out, but the truth is, to good programming is hard to do as well. Meaning that by the time you make some really good production worthy application, then it's going to have a lot of that thought process and a lot of the support structure put in place to help make that application a good viable product. But there's some other reasons why you should not do microservices. If you're looking at a monolith and that monolith code base is simply too small, it may actually be, well, it will be a lot easier and cheaper on you to just use feature flags when you have multiple instances of that monolith and use the feature flags to govern what each of the instances process. It is a lot easier to do those code changes and testing and etc. than getting out microservices. And if you're looking at your monolith and you've got that big ball of mud and you see just there's so much tight coupling going on at the code, you're going to have to spend some time refactoring. You're going to need to look at something like, with dependency injection and things like that to help break up the existing code so that's more interchangeable. And you still need to define out your team, your team structure. And if those team members are not willing to do microservices, or they're just not ready yet, they're not, maybe it's just simply knowledge, or what, you're going to need to get the team ready and built up so that they can actually do the microservices and support them, which goes back to that no support structure. If you're the team that develops the microservice, then you need to be the ones that support it. No other teams are going to know what the code does as well as you do, because you know that business domain better than the rest of them. And if you're not prepared to spend the high cost of time and money, don't do it. Like I said, there's quite a bit involved. So let's look at some challenges. And this is going to be a big, big topic here as we look at the challenges of making microservices. You may be expecting that they are cheap. Like I mentioned, there's a high cost of time, money. You need to spend the time investing. What learning resources should you be finding, and as well as the proof of concepts that you should be developing, and so many other things. And now that you got microservices out there, how are you going to call that microservice? Are you going to do it by IP addresses? So you can do RPC API type calls. RPC is that remote procedure call. Or are you going to bring in messaging, something like a direct commands or events, and pub sub? Or you can do synchronous type commands, or you can do asynchronous. There's a lot of structure on that. And I'll give you the biggest hint on that. It's not per microservice, it's per business process that you're trying to deal with in those microservices. So you may have a combination. And as you're getting your microservices out into production or into test or in your development environments, you may think you just copy the files over to a server. You really should set up your continuous integration, your continuous deployment pipeline per microservice. And as well, not just a pipeline, but a code repository. Build up a code repository per microservice. So why do a CI/CD pipeline and a code repository per microservice? Because they are independent applications, deserving of all the love and attention as any other application. They're going to evolve, and they're going to have their deadlines, and they're going to have their subject matter experts, etc. Right? So they're going to have that focus. They're going to have that love and attention. And now that we're talking with microservices over a network, well, now networking is going to have to be more of a responsibility of the developers. We can't just point it out and go, no, it's somebody else's job. Now developers need to know a lot more about with networking, but some things like the OSI model, specifically layer 4 and 7, which on my next slide, I'm going to dive into that. Security. Now this is a big thing. Now we're going to start learning a little bit more about security tactics as it pertains to network calls over the network and with our microservices. And you think, well, that's okay. We're just going to have our microservices be on a private network. No, you really should still look at encrypting your data in that communication. Think of it this way. What if that microservice is there to process your paycheck as well? You're probably going to want that communication secure. Here's the problem, and this does happen. Everybody's using like npm packages or NuGet packages. We're grabbing stuff off the internet. We're looking at, we're bringing in other people's code, but how many of you are actually reviewing that source code and rebuilding it yourself before you bring it and start using it on your applications? Very few of us do. And so the problem is, it may not be your microservice, but it could be somebody else's microservice that they brought in a package, and that code in that package may be sniffing the network and then sending data out. You have to be prepared for that. It does happen. So you do want to secure that communication as well. Maybe looking at something like OAuth, because if that microservice is processing your paycheck, you don't want any code to call it. You want to be able to restrict that to allow certain callers to that microservice. And now that we're talking about NuGet packages, and we're talking about maybe some internally made NuGet packages, when you have code, and I know we were talking about this don't repeat yourself, right? The DRY principle. I'm going to show you here in just a few slides why sharing code like that will actually keep your microservices tightly coupled and become a big problem. So before we do, let's take a look at the OSI model. The OSI model is the Open Systems Interconnection Model, and the point of this is to kind of kind of showcase the different layers that network traffic goes through as it goes from one system to another. The physical layer, that's that copper or fiber, the combination thereof, right? And that's when you get into the wires themselves that go in our homes and underground, etc. And then now, once they're plugged into a device, then that data is coming off the physical layer and getting to the data link. Then it goes up through layer three. So now we've hit an IP address. So maybe we're doing with Internet Protocol, the IP, maybe we're doing ICMP, which is ping, and that's handled at layer three. TCP versus UDP is the different types of packets on that call on the network. And so now the layer four deals with that different types of packets there. Now let's go on up to layer seven with this HTTP. So when we're looking at the HTTP protocol, that any of our applications that deal with that is done at layer seven. So why do we need to care about this? Well, if I've got multiple instances of a microservice, and let's say I'm going to go ahead and call them by an IP address, if I'm the caller, then that means I have to know the IP address of every single instance. But you really want to treat them as being ephemeral, meaning that they could go away at any time and need to be reinstantiated. So if that happens, then how do you know the new a new IP address of the next instance of that microservice? So what if you scale up? What if you scale down? So instead, what we'll use is use a load balancer. So I do a lot with Azure. So I may use an Azure load balancer. The way that the Azure load balancer distributes the load across the nodes in the backend pool is done on layer four. So that's how it handles traffic. So I know that it's handling it at the TCP versus UDP type things instead of the HTTP. It doesn't care about that kind of data. So why should we look at layer seven? Things like Nginx has a load balancer. And so you may be able to kind of balance your load even using something like Nginx, and it does that at the HTTP layer. Who else knows about layer seven? If you know about the MVC design pattern, right? The model view controller, what's the one letter that they leave off that we need? R for routing, because the traffic that's coming in gets routed to the controller. That's done at layer seven. So because of where these decisions are being made, that's why we need to know about the OSI model, not necessarily be experts on it, but know that it's there and understand how different load balancers operate when you need to design out your architecture. Okay, so we're going to switch gears and we're going to look at that problem case of sharing common code. So we look at the scenario where I've got two different teams, they're building two different microservices, and they're sharing an internally made NuGet package. It's not on the internet. It's inside the company. It's only internal intellectual property. But what happens is that the microservice A, that team has made a change to that NuGet package so that they can get their microservice to the next version and get that out to production. The problem comes when the other microservice is also dependent on that, and you actually cause a breaking change. And when you have a breaking change like that, you may have actually impacted the deadline of another team and their product. So how should we deal with this? I know a lot of us have heard of that DRY principle. Don't repeat yourself. Of course, I'm going to repeat myself all I need to because this is a good topic here. But the problem is that when we do duplicate, when we do not duplicate our code, it does make sense inside the domain that it's in, inside the code base that it's in. But now we've got different microservices and they are independent applications. So here in this case, it is actually better off to duplicate code. So now we're going to duplicate some of the code, bring it into their own NuGet packages as need be. And this sounds really weird, but here's the bonus of doing this. When you duplicate the code to the microservices that need them, you allow the microservices to evolve independently and they're not tightly coupled. And here's the thing, that duplicate code is actually not identical for very long. It's going to evolve. It's changing for a reason. What was a breaking change in one, maybe you just be able to duplicate and run differently. So they're really not identical for very long at all. So what should you do? Separate the code that changes to their own package for the microservice that needs it. Let me back up one step here because I got an interesting question for you. When we look at that common internally made NuGet package there, which team owns that? See, there's the other problem is when you have common code, who owns it? And without a kind of a definitive structure on that, you're going to run into other problems. Okay, so you're hearing all this and you're like, I'm not going to be swayed. I'm still so ready to do microservices. I just can't wait. I'm going to do this as soon as this talk is over. And so you start looking at your monolith and you start pulling code over into a new microservice, and you realize it has a dependency. And so you move that over, and it has a dependency. So you move that code over, and then you realize you didn't actually build you didn't build a microservice. You built another monolith is all you really have done. This is a bit of a problem, and can be a huge problem if you stop here. When you're moving over your code, you're realizing your dependencies, and you're realizing what things can operate and where they cannot operate by themselves. If you stop here, this is a bad spot to be because, like I said, you've just built into another monolith. However, if you already have it in maybe your backlog items or something, so that you know going forward, you're going to take that second monolith and you're going to go ahead and carve it into a better, well-formed microservice, then this is simply a hop on the road. If you have to go to production with this, maybe it's just buying you some time. Yeah.
Hey, Sean, real quick, one question we've got from Tech Workbench, I think regarding the shared packages. Are these different projects or just a branch of the project?
This is assuming that microservice A is an entirely different product than microservice B. And the point being that it doesn't, yeah, we can assume that they're in the same programming language, because it's going to be shared code like that. So it does make that assumption. The point is that they need to evolve independently. So it's really not about a branch of code. It needs to be, if they're going to be their own code repository, right? So then you can just go ahead and make another package, maybe put that into however you're going to build out your NuGet packages, because that's a whole different argument I've seen in multiple different ways of handling internally made NuGet packages. Should you have one repository per, or should you lump them all together in one? There's that you're going to have to iron out because there's no one solid answer on that part. So I hope that answered that question there. Okay. So we talked about building out another monolith, which don't do that. But if you are here, be sure to spend the time to finish carving that out to better formed, a well-formed microservice. Now we need to shift gears here because we have a big topic that we're going to have to discuss, and that is decentralizing data. See, the problem is that also with microservices, there's this rule that says that if a microservice persists data, it should have its own database. Now, I've done so many things like everybody else that has done more monolith, and you got a centralized database system, maybe in a full cluster of things, whatever. And you're like, no, we're not going to split up our database. That's just not going to happen. And try to have that argument with the DBAs going, well, no, this guy on the internet says you should. No, doesn't going to work. So I'm going to walk you through the scenarios and explain why they say that you should split up a database for each of the microservices that you make. And we're going to look at a lot of of how do you handle a lot of the different scenarios. So let's start with this one where I've got a monolith and I've got a single database. And it's got tables for accounts, customers, orders, orders history, parts, parts one, shipping history, and logging. And oh yeah, sorry about that. Yeah. Okay, so right. So let me do my other developer voice here. Right. So okay, so here's what happened, right? So as code evolves, right, as it does, code changes, it happens, right? So we had to change the table structure of parts. And as we were changing things, we're constantly adding columns and we're trying to add and we're trying to make some things happen, right? And we're just trying to do a little patchwork and trying to get this done. Well, we ended up in this change requirement that it just wasn't going to fit with the current parts table. So what we did is we went ahead and created another parts table, and naming is hard. Hopefully I'm not the only one that has ever seen that. So, and the look on Ash's face says a lot. So but see, that highlights the problem. See, just as code changes and we kind of grow into that big ball of mud, we get that spaghetti code, right? Because the code changes over time with all these weird requirements coming in, the bug fixes, etc. So does the schema change in our tables. So that's the biggest reason for splitting up the database, is because you're going to find contention in that. So as you have these schema changes and you're going to have the one application that says, no, I need it to be changed this way, but no, this other application says, no, I need it changed for me. Now you're tightly coupled. They're at the schema level. You need to break that apart. And because the microservices are the independent applications, the data that they house is also the single source of truth. Here's what I mean. Let's go through through this scenario of we keep splitting out these microservices. So now I have a parts microservice with its database, and I have an orders microservice with its database, and then I even have a shipping microservice with its database. Okay, well, here's the problem. Now we're looking at the business processes for each of these microservices. Shipping needs to have information about the orders that they're going to be shipping. Orders needs information about parts that belong on an order, but the parts microservice is the single source of truth. Okay, how do you handle this? So when a request is coming into the individual microservices, it's a viable solution to have one microservice that calls another. So the orders microservice simply makes a network call over to parts microservice and says, hey, I'm being requested for this information. I need information on these parts. You do a select and pulls that data. There you go. Now that's possible, and that's very viable. And this also, by decentralizing the data, it also allows you to choose different database types to be more performant for what you need on those different business processes. You don't have to stay with the original database type. So now I'm in a position where I've got a single source of truth. I've got microservices that need this data, so they can just do a network call and grab that data. That's a viable solution until. Now, if you get a few calls an hour, that's not a big deal. That's not a problem. But if you're anything like Amazon, right, they're doing tons of calls per second, you're going to see a very chatty network. And when one microservice has to call another microservice that calls another microservice to get information, then you have this chain going on, and it adds latency to the original call. And with that additional latency, with all those one calling another, it allows a higher opportunity for failures. So how do we handle that? We duplicate data. I know, sounds absurd. We just took a centralized database. Now we split it up, and now we're saying duplicate the data. Kind of, yes. Here's what I mean. As we look into the parts database, what kind of details do we have about a part? Remember, it's that single source of truth of everything about parts. So it's got an ID, maybe a natural key, part number, part name, etc., right? Descriptions and a color and the container, when the manufacturer, the manufacturer's part number, manufacturing date, the replaces what part number and discontinued date. That's great. It has everything to deal it needs about a part. But the orders microservice doesn't need all of that. For the order, the only information a part that it needs from a part is maybe the ID, the part number, the part name, a description, enough to fulfill the purpose of an order. It doesn't care about the manufacturer's part number or when it was discontinued, etc., because it's already been picked and it's already been placed on the order. So now you're not duplicating all of the data, you're only duplicating just enough from one microservice to another, just enough to help fulfill the business processes. Okay, so now to the next problem. See, if you haven't figured this out about microservices, it's never about right versus wrong. It's about trade-offs. You're going to have to find what's going to work for you. And don't be surprised if you make mistakes and have to re-engineer some things. So now we've got separate databases. We have different, it could even be in the different types of database. You can go from a relational like SQL Server to a MongoDB or maybe DynamoDB, et cetera, right? It could just be in different types of whatever is best fitting for you. But now that we got duplicate data, how do we keep them in sync? This is where communication matters. So you might bring in something like messaging. So let's go through an example. So we have this online order system. An administrator logs into the system and enters in information for a brand new part to the whole system at all. All right, so that message gets over. It is a command type message over to the parts microservice, and it says, all right, great, it's a brand new part. I'm going to validate information, right? And then it inserts that into the database. Now it's available for an order. Okay, great. Now a customer comes in, they log into the website, they find that part, they place an order. Now look at the different type of business process that we have. So now a message, a command gets sent over to an order microservice, and it creates the order, and it inserts information into the parts, into that database. And it grabs information from the parts database that is copied over into that order microservice, to that orders database. And then it can send out a update that message that the order's been placed, and now the customer is emailed and says, great, I've got my order. And then the shipping department is also able to react on that message. But the customer lets the administrator know, says, by the way, there's a major typo in the part description. Okay, so the administrator pulls up that part information, fixes the typo. Different business process. So now a different message is sent for a part update. Maybe it's part description update, whatever you want to name this event. So now this event gets out, and not only does the parts microservice react to it and finds that part in its database and updates that description, but the order microservice reacts to it and says, well, I'm going to ignore all the closed orders, but I'm going to look at all the open orders. I'm going to go find where I've got orders with this part information, and I'm going to go and update the description there. So now using business processes and events and messaging, you're able to keep multiple microservices in sync with the data changes. Now, let's go a little further with messaging, because there's a different type of messaging that we need to look at. What if we need to use sagas? Let me give you a scenario on this one. So in the real world, I have a separate checking account for all of my internet-based purchases. So that way, if I'm buying something off of not just Amazon, but any other kind of website, right? But if it gets hacked for whatever reason, if that checking account was to get hacked, the most they're going to get is maybe the $200 I put in there. The point is, it's not the checking account where my paycheck lands, right? So I'm kind of doing a little protection there. Okay, but so as it happens, though, is that I will forget the balance and I will go and purchase something. And then there's that time, certainly with Amazon does this, where I will go and I will place an order for something, and I get an email. It says, thank you for your order. We'll get that shipped to you as soon as possible. And what happens is that a saga is created, an order saga, there where that order is a saga message itself, and other microservices are reacting at different times and doing different transactions, but connected to that same order. But they're able to do their transactions independently and over time. So the order gets created and I get emailed, but the payment microservice picks up that information, attempts to do a payment, and it fails. So it updates the saga with, hey, there's a payment failed event. The order microservice reacts to that and then sends me an email saying there's insufficient funds. There's a payment problem. You need to get this fixed. Okay, makes sense. So I log back in and I move money back over to that account. I go to Amazon and I say, okay, go ahead and try that again, please. So now that it updates that saga and says, all right, there's a reattempt on payment. So the payment microservice reacts to that event, process the payment. This time it succeeds. So they update that saga. So now it says that payment has succeeded. Now the order information is updated and the shipping microservice reacts to that now with that event saying, okay, great. I'm going to go grab that inventory, get it boxed and get that sent. So we're able to use a saga in the messaging per order to help understand our transactions as they relate to individual microservices. It does not matter about the code. It doesn't matter about how the data is stored. It's just a way of doing a common communication that way. Okay, let's shift gears one more time. And we're going to get into to decomposition. Okay, like I said, this is going to be very high level because if we were really to do this justice, like I said, we'd need to do a workshop, and it'd be a good 5 days, all day type workshop to do this well. But when we're talking about decomposition, what we're talking about is grabbing existing functionality that belongs in a monolith, and we're extracting it out to a microservice to itself. Now, I don't know about you, but I've never worked on a monolith where the independent functionality across the domains was so cleanly defined as this. It usually looks more like that, where the boundaries the boundaries are not clearly defined, and they lack dependency injection. And it needs a lot of refactoring. So when you look to finding some piece of that code that you want to move over to a microservice, you're going to have to make sure that you can do that cleanly. So let me quickly answer a question that I usually get, and that's, well, how do I get started? And this is going to be my best advice that I can give you here. Find the smallest piece of code that you want to move over into that microservice, the smallest piece, because it doesn't matter about the size of the code when you still have to build out your new code repository. You still need to build up a CI/CD pipeline. You got to get your team members set up. You have a team structure, and there's, and your support structure. Maybe you're going to do some other analytics about the project itself. I mean, there's so many things that you're going to have to get in place, that infrastructure of that project, regardless of the size of the code. So in order to get started and do it on the right foot, build up that infrastructure first, understand what you're going to need, figure out your business processes, how are they going to communicate to that microservice, etc., and using that smallest piece of code. Okay. We're going to talk about decomposition. We're going to look at using domain-driven design. We're going to talk about domain-driven design, but it's not the only way of doing decomposition. It lends itself really well for microservices, but it's not, DDD was not created for microservices. So we understand that. So as we look at domain-driven design, the thing we're going to focus on is, what is a domain? So we're looking at this company, Wham Bam, and they make fidget widgets. And the code that we're going to focus on is for the production stuff, to manage the production of the fidget widgets. Now, there's other domains that go along with this, and this is, so you have the secondary domains, and now you're looking at purchasing and shipping. You have to have purchasing so that we can get the raw material for production to build a final product so that shipping can get that out. Then you also have generic domains, things that are more easily replaceable with off-the-shelf items, off-the-shelf software products. So things like your third-party systems integration, maybe accounting software, invoicing management, returns management, etc. So when we're looking at what we need to focus on here, we're looking at the different types of domains. One of the best ways to do this is through a workshop called event storming. And you can look at in Ash or Callaway, if you don't mind, put eventstorming.com in the chat. Eventstorming.com is a great website for them to check out later. Event storming was created by Alberto Brandolini, and it is a workshop where the developers get together with subject matter experts of the various domains. And you grab a stack of different colored sticky notes, grab like a long wall, put some butcher paper on there so that you can draw your lines, but you can have your sticky notes on there and be able to roll that up for later. And as you're looking at understanding the business processes, you have subject matter experts that are writing notes on the different colored sticky notes. But different colors represent different things. Something like a domain event, such as an invoice has been paid, and an invoice has been canceled, and an invoice is failed, right? You know, it's just in a bad state. And they handle the paperwork and we write the codes to help them do their work, right? So how do things get processed? How does the business process flow? And as we're looking at the different things as how things work, and we're understanding from the subject matter experts how they do their jobs, we're going to, in particular, we're going to pay attention to two different of these domains here, purchasing and production, for this example. And so we're on the board and we see these domain events, we see the actors, we see the commands, we see the aggregates, etc. And one of the things that we're able to notice is that there's a lot of functionality that belongs together. And that's everything to do with purchasing. And over here on the board, we see all this common functionality that has everything to do with production. Now they may talk to each other, and they have some coordination together, but really the functionality is independent, production versus purchasing. And what you're able to see is, you know what, if we were to draw a circle around this common functional area here, it's a context, right? And in fact, that's what domain-driven design calls a bounded context. That bounded context is a way of grouping like functionality together that is still separate from another context. Now, we're looking at context and the differences thereof. And one of the things that we've noticed is that, well, there's parts and parts. Well, and we go, okay, so what do you mean by parts? Oh, well, this is the raw material that we're talking about. Okay, but what's this part? Well, this is actually a pre-step. So what we do is we take raw materials and we assemble them so that they work with other assembled parts. We don't sell these, but these assembled parts come together to become a final product. And those final products are what we sell. Okay, so we have parts and we have parts. With domain-driven design, one of the main tenets is that we use a ubiquitous language. The premise here is that we change the names of things so we help remove ambiguity. And so much so that the suggestion is that even with our namespaces, our class names, our method names, change the name so that they are more in line with the context that it belongs in. If I was to say we need to go and create a new account, what kind of account? Well, it depends on the context of what you're talking about. Is it a customer account? Is it a checking account? What is that? So when we change even our method names to go create new checking account, then any new developer to the team is able to look at that and immediately know what that refers to. Okay, so one of the things we're going to do now is we're going to look inside the bounded context for production. And we're going to specifically look at the order functionality and the product's functionality. And now we get into code level discussions here. Now, this is not going to be something you do on the event storming workshop because that was more about business processes. But now we're at the code level. So now we have a class for order and we have a class for order line because an order is made up of order lines. So you have a dependency there. And a final product is made up of assembly parts. So the functionality to support a product has another class for assembly parts. And those are our aggregates. And you see the order aggregate and the product aggregate. But more specifically, we have that top level class. So now we have aggregate roots. So we have an order aggregate root and a product aggregate root. Now, one of the rules of domain-driven design is that any code in an aggregate can call another aggregate as long as it calls functionality that is exposed at the aggregate root. Think of it this way. If for whatever reason we have code in the order line class that wants to call code over in the assembly parts class, in that instance over there, it has the potential of changing state. It could do that without the product class instance knowing it, meaning that you risk data integrity. So by sticking to the rule that any code in an aggregate can call another aggregate as long as the functionality is exposed at the aggregate root, the aggregate roots can help protect data integrity. And you're thinking, well, okay, but I got to call this class and that functionality is not there. Then you have to provide it at that top level class and provide the judgment call on how you're going to do that. Now that we're talking about exposing functionality at the level of the aggregate roots, we're looking at, well, what could be called, how would it need to be accessed, and for these different processes. And then you go, you know what, we could wrap this together, and that could be the functionality that we expose for this microservice. So now we kind of identified from maybe an event storming session where we understand some business processes, and we got everybody on board, and we're looking and finding things that are common terms that need to be re-identified. So now we're working on that ubiquitous language to remove some ambiguity. And now we've identified some functionality that we need to expose at the top level classes, those aggregate roots. And now you say, all right, this is some functionality we're going to expose as a microservice. So now there's also another rule that says, if we're looking at this, that we have a microservice that is containing a bounded context. You can have a microservice that has multiple bounded context in it. But what you will not have is a bounded context that is shared between multiple microservices. Don't do this. Now, I say this, of course, there's always going to be that one little exception to the rule, right? What I'm saying is, the bounded context that has business logic do not share across different microservices. Because who's to say that that microservice owned by one team may not be owned by another team later? Because your team structures may change over time, just as the code does. People hire, people fire, right? They change. Now, here's the exception to this. So far, I was talking about business logic, but what about cross-cutting concerns? As you're building out your microservices, you're going to go, well, we need a log aggregation system. We don't want it to change per microservice. We're going to use one log aggregation system, and we're going to do one way of capturing metrics. So now it's not about business logic. It's about supporting the health of each of the microservices instances that you have. So that code can be common because it's not about the business domain. Okay, it is time, guys. It is time for a wrap up. Let's do a quick review. Don't do microservices. I'm kidding. Microservices are very hard. There's so much involved in doing them and doing them right, doing them well. Be prepared to spend a lot of time and money learning, trying it out, proof of concepts, and taking a few steps back to reorient, etc. they do require a lot of good analysis and teamwork. You're going to have to work together a lot on this. So remember, with team autonomy, it allows you that team to have that choice of the best programming language for the job. C# versus Python, depending on your business needs, for example. Also have service autonomy, and microservice it exists independently because it is an independent application, and it should be able to be deployed without any other microservices, else you are tightly coupled as well. You want to stay loosely coupled in the domain that it's focused on. If you have a microservice that processes invoices, do not have it also handle scheduling, for example, right? And don't be surprised if you end up with a microservice that's growing in its domain and it's doing too much. And now you find a new pain point. So now your accounting microservice turns into an accounts receivable microservice versus an accounts payable microservice. That's okay. But again, a new repository, a code repository, and a new CI/CD pipeline for each, because they're independent applications. Microservices provide you some scalability options so that you can choose the number of instances that you need, the type of RAM and CPU, and what kind of server should they be on. Even operating system. You may start it out with Windows, but using .NET Core, now you're able to go to Linux, etc. And you get fault isolation. So if you have a business process of a microservice calling another microservice, but you hit an issue, you're not taking down the entire system. As you look at defining your microservices architecture, look at the way they're going to communicate. You're going to have to understand the combination, even if it is a combination of the different types of calls. You may do REST API as well as messaging, but it's to the business process that you're fulfilling these, not to the individual microservices. And yeah, CI/CD pipeline and a repo per microservice. I'll say it again because it's one of the favorite things, I guess, is they are independent applications. They need all the love and attention as any other application. Sharing code between the services keeps you tightly coupled. Stay away from that as best you can. It is okay at that point for those reasons to duplicate your code because it will not be identical for very long. It's part of what allows them to evolve independently. Now, as developers need to start learning a lot more about networking, specifically on the OSI model, layers 4 and 7, because of load balancing options. And secure that traffic. What if that microservice is to process your paycheck? You want to protect that information. And you want to judge who can call that microservice and get hold of that information. So you may look at something like OAuth or other options for governing access. Then we talked very quickly about using domain-driven design to understand our bounded context and aggregates to understand how we're going to get to some functionality that we may expose as a microservice as you're going through this process. So here's some recommendations that I have. The Microservices Patterns book by Chris Richardson. Domain-driven design by the guy that created it, Eric Evans. Patterns, Principles, and Practices of Domain-Driven Design, PPP of DDD, by Scott Millett and Nick Toon, which I highly recommend that book as well. Even if you read the one by Eric Evans, the way that Scott Millett and Nick Toon have approached domain-driven design, their examples, etc., that really helped click for me. So I really appreciate that book. The other one is Monolith to Microservices by Sam Newman. And that is it for me. My name is Sean Whitesell, president of the .NET User Group, Microsoft MVP. I'm a cloud architect at TokenX. And yeah, I am actually on Twitch. I don't stream very often, but I do on occasion. And I will get to that as soon as I can. But I do also have a meetup, TulsaDevelopers-net. And in fact, we're meeting this Thursday. I got a special guest, Scott Hunter. So you're welcome to come visit us as well. So that's it, guys. Thank you very much. And what questions can I handle?
Yeah, so Sean, thanks so much for that. Tech Workbench has a question. How do you usually keep costs down?
Don't do microservices. I really, microservices are going to generally, I mean, because there's so much more involved, you really want to make sure that the pain point that you have is worth the need to do microservices. Now, anybody that has done microservices is going to tell you, yeah, that's very, very true, right? There's so much to that. Like I said, you might have a better option of using feature flags with a monolith and just have different instances of that monolith. And then with those feature flags, you're governing what's being processed. Ways to save money is Look at what language you're written in, because things like if you're using .NET Framework, you're restricted to Windows, but .NET Core allows you to use Linux. So now, certainly in Azure, the cost of Linux is about almost half the cost of Windows. It's because you don't have a license to pay for. So, look at those kind of options there. And and literally like free training, because so much out there. There's definitely some great training that's paid for. Certainly O'Reilly has some really great stuff on there, but there's definitely some free options as well.
All right. And Sailfish
What else?
says, consider a portal with both static HTML content like TOS, FAQs, privacy policy about us, and some dynamic form elements like contact us, demo request, login. Does it make sense to decompose each of these dynamic form elements into a microservice?
I would not. Um, Things that can be fed by a CDN should be, and it's really, but it also depends on what you're serving up to. If you're a small organization, you may not need a CDN. Um, so generally, I treat microservices as handling back-end business process stuff. So you may still you can use a microservice to doing your front end work, and that's okay. But I would, for the static stuff, have that just be sourced from a CDN, even if it's off the same either CDN or maybe off the same server. But when you get into heavy spas where you do have individual component areas, look at Amazon. I should have mentioned this earlier. If you go pull up an item on Amazon, that one page is fed by many microservices. The part itself, the description, the images that go with it, the suggested items that you may like, the reviews and the stars, right? Those are all fed by a series of other microservices, and like your billing options, etc. Right? So it's okay to have multiple microservices feeding that one page. The other thing that allows too is, what if that microservice that's feeding all of the reviews fails? It's not available. Well, it doesn't stop you from still putting it in a cart and paying for it. So that business process, right? You got that isolation, even though it's on one page. It's just like, well, okay, well, there's an area that didn't show up. So you're able to have some of that fault isolation. So hopefully that answered that. What else?
Yeah, folks, keep the questions coming. We have put a link, Sean, to the Tulsa Developers Group. You said you've got a meeting this Thursday as well?
I do. Thursday night with Scott Hunter, who's the top guy at Microsoft over everything to do with .NET.
Excellent, excellent. Yeah, looking forward to that one. Sunday DriveCon says, it sounds like the critical component is messaging. How do you develop knowledge of all the types of messaging options to make intelligent choices? I don't know of anyone that has enough expertise on all messaging options.
And that's a good point. What I would do is I'm going to look at what's going to help me the most in the easiest way possible. And the only way to do that is by doing some proof of concepts. Make out several different, like, for example, I do a lot with .NET. So I'm going to do console applications that fire up RabbitMQ and talk to each other that way. And then I may even add a layer and use mass transit. Mass transit can use RabbitMQ, and it actually provides some things that RabbitMQ does not. So it actually adds a layer there. So by doing those test projects, it's not, you can say it's throwaway code because it's not bound for production, but it's there so that you can learn with, right? And I have a ton of those where I just go and play. I'm going to go try this out. I'm just going to make yet another console application 74, console application 75, all right? Because naming is hard. So definitely attack that. And if I can recommend another streamer, Oh, good Lord. You know who I'm talking about, Terry. Oh, good Lord. His name will hit me here in just a minute. He talks a little bit about Kafka and using Kafka as a message broker. So there's even options there. So, oh my God, I can't think of his name. Hopefully you know what I'm talking about. He's out of Jersey. All right, it'll hit me in just a moment. But anyway, the thing is just trial and error. Proof of concepts, left and right. What is the easiest way to get from there to what you need? Chris Patterson, who co-created Mass Transit, mainly the main author of Mass Transit, he is on Twitch now as well. I think, and I'll put this in the chat here. If you want to find the Twitch link for that one, he goes by Fatboy G. He's got he streams on Twitch, and he's got where he'll step through and developing code using Mass Transit. So it depends on the working programming language that you're using.
Yeah, and the great thing is that this is software. It should be relatively easy to change. Now, if we're talking about a re-architecture, maybe there's some nuance in that, but
Yeah.
it's not set in stone. We should be able to adapt. It should evolve. It should hopefully meet the business's needs.
And what he mentions messaging. So that is a good way of having several microservices to be, like certainly if you're going to do like a pub sub model with the messaging. So all you're going to do is publish this event. It doesn't matter who receives it. So it doesn't matter if there's 2 microservices or 15 that react to it. The provider doesn't care how many consumers there are. So if you're able to go and just add a new microservice and say, well, these are the events I need to subscribe to, great. Then you've got a very loosely coupled architecture. You're just able to add the different microservices there.
All right. And Basebleem has a question. Are there recommended strategies for full stack automated testing across microservices?
Okay. So I won't say full stack because that, even with microservices, like we were talking about earlier, that could include the UI. So that's going to be slightly different. With microservices, you still have a code base. You still want to be doing unit testing. Absolutely do unit testing, and as well as you can, be it X unit, in unit, whatever. If you're using a REST-based API call from one to another, there is a way of doing what's called a consumer-driven contract testing. And I'll put this as well in the quick message. There is a library called PactNet. Now, PactNet is for the .NET stuff. There's where I think it's pact.io. And for if you have if you're working with a different programming language, I think they started with Ruby. I'm not sure. And the idea there is that if I'm running a microservice that is calling another microservice, so now I'm a consumer. What I'm going to do is I'll write my test and using this library, and it stands in as a mock. So I give it a port number, and when I run this test, it fires up. But one of the things I've defined in that test is here's what I'm going to send, and here's my expectation of the return. This library pops up. It's the mock. It receives that information, and it also writes out, and it has an output file. So then you're able to write the test and looking at that information and go, okay, well, I went and changed something about the contract. The contract is the payload, right? What does that payload look like? If I'm calling Callaway's microservice, then here's the payload, here's the fields, etc., that is expected to be sent and processed. Well, if I change that and I rerun my test, it's going to say, you're going to call a microservice, but you have broken something. Now, here's the cool thing about this is that output file can be used by the provider microservice. Now, this does assume that this is all internal. If I'm calling Google, they're not going to care that I'm calling their stuff. They're not going to change. But if I have another microservice that is being called, so now it's providing information, they can write, the developers there, you can write test that with the same library and say, well, here's my output file that was created for me by the consumer. And it's a way of testing to make sure that that contract that is expected is being adhered to. So that's one way of doing, well, if you're going to use REST-based APIs. I say REST, if you're going to do API type microservices communication. If you're using messaging, now specifically in mass transit, because I mentioned that earlier, mass transit has a test harness. So you're able to write tests that use a test harness. So it has a pretend bus, if you will. It's an in-memory bus. And you're able to write your test that says, was this sent? Was this consumed as I expected? So you can use, so like I mentioned, PackNet or Pack.io, check that out for doing contract testing that way. And with messaging, specifically mass transit, look at mass transit has a test harness in that library.
Okay. And Tech Workbench says, how do you deal with consistency and eventual consistency?
Messaging. That's, in fact, let's go back to here. Okay. So, love or find a way, convince yourself, whatever you need to do, find your ways to love eventual consistency. It's around us already. It's in our everyday world. We're already used to it. We just may not realize it. Here's what I mean. So John Calloway is just so impressed with this presentation. He's going to send me a check. All right. So this check for a great $1. It eventually that check is going to get to me, and eventually it's going to get into my checking account, and eventually it's going to be in the processing that they do nightly, where now it's considered not just a pending credit or a pending deposit. Now it's actually there. And I go, great, now I'm richer by $1. So eventually that information is going to get there and be kept in sync, because now he already knows that, well, there's $1 that went out, and I eventually will get that, and then he can eventually know that I got it. So, all right, that's a really weird but true real world scenario, right? When in the case of the administrator that's updating the information about a part description, now you could not use messaging and you can do direct API calls if you want, if that's the way you want to do it. Then you get into a position where you have one process that's in charge, be it your monolith or a microservice. And it's in charge of making sure that the other instances with their databases, that you've got your data, good, you got your data. Okay, which is called orchestration. You can do that. That's a solution. Or you can do something like messaging, which you can also do choreography or orchestration through messaging as well. And the idea is that you want to post your changes on a message and allow the different microservices to react independently, but through, they're connected at that business process, such as description updated. Then they can react and as they need to. That's going to be your way of keeping your data in sync in that regard. The transactions themselves are between the microservice and their own database. Don't attempt to do distributed transactions where I've got this transaction that is requiring shipping to complete, and as well as the parts database to complete, as well as others, etc. It's too prone to problems. But if you use something like a Saga, then you can still have that consistency per microservice per purpose. Like in my example, the order saga is that purpose. And it allows that consistency to be changed and spread across, but as well over time. Because what if I don't log into that order system for quite some time and update my payment information? Well, they're not going to ship me the product, but it could be a day later, 2 days later, and I finally go in and go, oh, shoot, I missed this. Update my payment information. They retry it, even though it's days later, but it's still connected to that same saga. So it's a way of allowing individual transactions stay isolated to the microservices and yet connected at the purpose of the business processes.
All right, and
What
we've
else?
got a comment from Sailfish. I get that in the pure sense, data should be broken out to map to a specific microservice. However, practically, I'm struggling with the loss of relational joins. It seems that you must add a lot of complexity and overhead to segregate at the data layer.
Okay. So let's go back. Let's go back to here. And it's a very valid point, right? Is we started with a relational database, and now we're being told to split things up. Now, I was talking with a Mark Richards. I've got his book on right here with me, Fundamentals of Software Architecture, and I was talking about Mark Richards about this, and his rule of thumb is, if you've got one or two microservices, you're probably not going to be hitting the contention and you're going to be just fine. Okay. There's no magic number, but at some point you're going to have enough microservices that you really need to start splitting up the data. My examples here are assuming that position so that I can go ahead and explain the why and how do we get there with this decentralized data. So if you only got two microservices, you'd probably be just fine. What do they need? So when we were looking at this type of system is where we're looking at what is this order microservice? What data does it really need? And because it only handles orders, you notice that it doesn't handle scheduling, right? So those kinds of things are not in this database. It doesn't handle the scheduling. It doesn't handle returns management or things like that. So where you need to slice up your data when you're looking through a relational system is find the domains that the tables and the data that support the individual domains, because that's going to be your main uh, slicing spot, if you will, and find out the things that stay together. Now, if you're going to like, well, I've got all these joins because I've also got reporting. Well, that's a different thing too, isn't it? So now I'm reporting off of the parts table because I need to know. Let me change this around. I've got an inventory table and I've got an orders table, and now you've broken my join because now I can't get that data. Well, what you do, one too far, is now you have a microservice that is feeding maybe a reporting microservice or a data warehouse. So now you can use something like your messaging or a sagas, and maybe instead of a shipping microservice, maybe in addition to, maybe you have a reporting microservice, and it's receiving the information it needs. It's not part of the business process, but it's capturing information sent to it about the business processes. So now your reporting doesn't have to go across multiple microservices and multiple tables that way. Now it's going to one. And depending on the size of the architecture that you have, basically the larger the architecture you have, the larger the need for a data warehouse solution. Because then you can separate the use of the data of how it's created versus how it's read. So now if you think about it, now we got this reporting microservice that's receiving this data, and all it does is write, all this data coming in. Then I have another reporting microservice for handling all the reads. So now the read though it's not querying the exact same model of what was written in. In fact, it's maybe reading data that's been processed and stored in the database. Maybe it's got computational computed fields, or maybe some other logic, maybe built over time, etc. Right? So now what I've just described is a design pattern called CQRS, which is command query responsibility segregation. So now as I'm writing information to the data warehouse, that is for one model, but I have another microservice to support a different model of how the data is being read. Now I can expand on it a little bit more, but so there's even different design patterns to help support that. So hopefully that in a nutshell kind of helped answer that question.
Yeah, we don't have anything else queued up at the moment, but Tech Workbench says, thanks, Sean. And of course, we'll echo those sentiments. We really appreciate you chatting with us and presenting to the stpete.net meetup. Folks in chat, if you have any additional questions, please feel free to include them here. We'll make sure that Sean sees them and addresses them. There is a few second delay, so we'll buy some time here by continuing to talk a little bit. Like I said, like Sean mentioned earlier, this Thursday, there's one of the Scots coming to speak at the Tulsa user group. So we'll be sure to tune in for that as well. I'm not sure if we host your stream as well on the Six Figure Dev channel, but we'll make sure that it is it going out on Twitch, or is it on a private chat?
I have not set that up. Yeah, okay. It's if you go to that meetup and you RSVP there, you get the link there. It's with WebEx.
Okay.
I have yet to set this up for Twitch. Just a bridge I haven't crossed yet. But we'll work that out one of these days and get that started. And by the way, too, is that we meet twice a month, and we're gonna get ready to be meeting in person sometime this summer anyway. I'm still waiting on the venue. And what we're going to do is we will still have our virtual meetings as one of the two, and then the in-person being the other one. So that way we can best of both worlds in a sense.
Okay.
Thank you guys very much for having me. I really appreciate it. This is fun.
Yeah.
And those are great questions too, by the way. Those are really good questions.
Yeah, I really appreciate it. Chat, really appreciate you joining as well. And like Sean mentioned, great questions and contributing there. Basically says, thanks, great talk. I'd enjoy DDD as another discussion topic. So we'll see if we can't make that happen. I'm sure between the stpete.net meetup and maybe the Tulsa group as well, we can probably make that happen at least once, if not twice, for a couple of different groups. We'll be looking to get back in person at some point as well for the stpete.net meetup, but we will continue the live broadcast here on Twitch. If you want to get involved, if you want to suggest a topic or suggest a speaker, if you want to volunteer to be a speaker yourself or volunteer yourself or a coworker, then we'd certainly love to have you join in on the conversation on Meetup, on the discussion boards. Follow us on Twitter, join in on the Facebook groups as well. John Ash, want to appreciate say thank you for filling in for Clayton, running the back office here for us on the stpete.net meetup, hosted on the Six Figure Developer channel. Clayton is away with family on vacation. I myself am remote this week on vacation as well, but we wanted to make sure we got this out to all the folks joining. Tech Workbench says, Sean, do you have any advice on development using Docker to create microservices?
I would say definitely look into using them, but they're not required. They provide some really good quick way of doing some things. I say quick way. It's a way of the whole reason for Docker type containers to exist. And by the way, Docker is only one type of container. Rocket is another type, but Docker is just the one that most people have heard of. I would also look at, if you're going to do that, is look at doing Kubernetes, because when I talk about managing multiple instances of a microservice, what if one goes down and you want to be called at 2 a.m. just to go create a new one? to fire it up, and it takes less than 5 minutes. Whereas Kubernetes would have already solved that problem for you. So by at least spinning up a new one. So, but then again, Kubernetes is its own ball of wax, and it's got its own learning curve. So, but I would definitely say look into it. Not required, but look into it.
Okay, great. Yeah, and Martin says lots of great info. Thanks. So with that, I think we're winding down here, folks. So if anybody has any final words or final questions, comments, etc., feel free to drop those in chat. Sean, if you have any final words for the folks here, we'll look to raid others. So if anybody has any suggestions on that as well, feel free to drop that in chat. We've got some options on JBlow, Mastermind, Fierce Kittens, Jispo, Calo Creations. TBD Gamer is working on Contentful blog using Blazor, so that's always fun. So that's
who I was thinking of. I don't know why that name just escaped me. TBD Gamer.
Yeah,
that's who. Because he has some experience with Kafka, and he's been talking about that recently on his streams. So that's who I was talking about.
All right, fantastic. Then we will take that cue, and I'm tuning in here just to double check that he is indeed live. There is a screen with a solution up on it, but I'm not seeing a whole lot of movement. Am I paused? Is it going? Yep, there we go.
He may be talking, and he's not. His camera may not be on.
Yep. So we'll take that cue, and we will raid our friend over at TBD Gamer. Again, folks, thanks so much for joining in. This is the stpete.net meetup hosted on the Six Figure Developer channel. The stpete.net meetup will be back next month, second Tuesday of the month, every month. So please do like, subscribe, follow, join us on meetup.com, follow us on Twitter and YouTube and all that fun stuff. Ash, how did John manage to go on vacation? Well, I traveled with a laptop and 3 microphones and somehow ended up here. Clayton got away scot-free.
Yeah,
so
I don't know how that happened.
We'll be back on this channel for the Six Figure Developer podcast. We'll actually be recording and live streaming 2 podcasts on Monday, and should be back for the live stream, live coding, live Wednesday evening next week. So if you like that sort of thing, feel free to join in and tune in for that as well. Again, Sean, thanks so much for joining, and we'll look forward to your meetup on Thursday.
Awesome. Thank you for having me. Thank you for all the visitors. Thanks for coming. Those are great questions, and I appreciate it.
Yeah. Thanks, everybody.